Hello, my name is Kostyantyn Kravchenko. I'm a data analyst at Data Science Group for the SoftServe company, and this is my Capstone project presentation for the Advanced Data Science with IBM Specialization. Let's start with the stakeholder presentation. This project is to predict average spend in holidays resorts. The problem statement and data was provided at online hackathon in association with Analytics Video website. The company is one of the biggest resort chains in India, which makes a significant revenue from food and beverages sales in their resorts. And given information related to resort, club member, reservation, etc., the task is to predict average spend per room night on food and beverages for each reservation. This is a regression problem, and we will train a machine learning model on the provided data to give the predictions. The dataset contains more than 300,000 observations with 24 variables, 11 numeric, 14 categorical, and 3 date variables. The variables have been anonymized, so the categories like resort, state, and region were replaced with codes, and the target variable, being amount spent per room night, has been scaled. You can see the correlation matrix at the slide, and the variables which are most correlated with the target are the total number of persons traveling, number of adults traveling, number of room nights booked, and different channels for booking, as well as state in which resort is located. There are several benefits for prediction model. First of all, is improving the pre-sales during the resort bookings through web and mobile application. Targeted campaigns to suit members' taste and preferences on food and beverages, providing members with the customized experience and offers, and also inventory planning for food quantities to be prepared in advance. The data preparation and model training is conducted with the IBM Watson Studio. It uses Python, scikit-learn, and Jupyter technology. And afterwards, the service is deployed with IBM Cloud. So the architecture is user-provided CSV file, uploaded to Watson Studio, processed with the Python and Jupyter, and then deployed as a web application. Next, let's see some technical details. So the core solution is user-provided CSV file uploaded to Watson Studio, IBM Object Storage, the scikit-learn and Python and IBM Watson Studio with Jupyter notebooks. There are several notebooks created for the project and documented in ADD file. ETL, data exploration, feature engineering, model definition and validation, and the final pipeline notebook, which takes the raw CSV data and outputs the trained pipeline ready for the deployment. The trained model is saved and deployed as Flask REST API with Dash user interface hosted at IBM Cloud. There is an alternative solution, which is IBM Watson Studio Data Refinery Flow for raw data preparation, and Watson Machine Learning automatic modeling deployed as REST API web service. The data preprocessing and feature engineering stage consists of 3 steps: exploratory data analysis, feature engineering, and pre-processing. So there are 24 variables with more than 300 observations. The data is rather clean, so there is only 0.1% of total values missing, all of them coming from the resort type code variable. There are 3 date variables which should be parsed to date time format at data loading stage for further feature engineering. There is one variable with really high cardinality with more than 100,000 unique values, which is member ID. And there is one variable with more than 77% of 0 values, which should be accounted in data preparation. The feature engineering mostly takes advantage of date features, creating new features like booking in advance, days stayed at the hotel, as well as other features containing the information from the date, like month, week, day of the week, is it a month start, month end, etc. And some other features like total number of people and other. The preprocessing is really easy, so there are 4 steps. Filling NA values with -1, converting the binary type columns values to 0 and 1, one-hot encoding for categorical features, and scaling the numerical features. The model is evaluated on root mean squared error, RMSE, between the predicted value and the observed amount spent. So the train valid split performed based on the member ID variable to prevent the data leak. So we want to be able to predict the amount spent for the new members of hotels, and splitting the data based on member ID allows us to train on one set of member IDs and validate on the other. The chosen model is linear regression with regularization, also known as ridge regression. Model parameters are tuned on 5-fold cross-validation and stratified by member ID groups. The model performance is then validated with unseen data. The model is trained and cross-validated in just under 2 minutes with Watson Studio Lite plan, 1 CPU and 4 GB of RAM, and shows the RMSE score of 0.9157. After model training and evaluation, we create a separate Jupyter notebook with the full pipeline, which loads the data, does the pre-processing, creates and saves the sklearn pipeline object to pickle file, which will choose columns, transform columns, and train the model. The fitted and create pipeline is then deployed as a Flask REST API service with a minimalist web interface created with Dash running at IBM Cloud. Let's now see how it works. So here you can see the web application interface. The booking date is chosen automatically based on today's date. We can choose the reservation dates. Let's go from May 26 to May 31. You can see that we have selected 5 nights reservation. Let's choose 2 adults with 1 kid. Region number 3, which dynamically chooses 2 states within this region. Let's choose one of the resorts, and we get the prediction, the spend prediction being 7.21. It's not very informative as the data has been scaled, but we can tweak some parameters and see how the prediction changes. Let's say we now choose 3 adults. And let's change the region and the resort. You can see the spend prediction went down. Let's now choose 4 kids. Alright, and the spend prediction went up. Also try choosing more reservation nights. So if we choose 26 nights of reservation, the spend prediction goes down, as this is an average spend per night. Okay, I hope you enjoyed my presentation. Thank you and goodbye.